find the derivative of the function log base 9 of 5 plus radical x. When we have a log of a base that's different from e, we may wish to use the change of base formula to turn it into a base of e. The reason why a base of e would be preferable is because we know the derivative of log base e of x. So see, log base e of x is the same as the natural log of x. And we know that natural log of x has that derivative of 1 over x. So that's what we'd really like to have, is a base of e, so that we could find that easily. So the change of base formula, if we were to apply it in this case, like let's say you had a log of a weird base, and you're trying to find the derivative of that. First thing I would do is use the change of base formula. So change of base formula says if you're taking a log of an unusual base of a thing, you can rewrite that as a log of a base of your choice, such as e of that thing, and then divide by log base e of the undesired base. So this translates to basically ln x over ln b. So we could rewrite this guy, log base b of x, rewrite him as ln x over ln b, and take a derivative of that. What would we get? So the 1 over ln b is like a constant. And then you can pull it out front like you could with any constant. You know, when you're taking the derivative of an expression and it has a constant factor in it, you can pull that factor out. So we would get that this is 1 over ln b times 1 over x, which simplifies to 1 over x ln b. So that's what I would use here, is that derivative, that the log base b of x has a derivative of 1 over x ln b. So try to use that. Let's see, we'll take a derivative. I'll do it down here. It's going to be, first of all, we have to acknowledge that there is a chain rule that's going to happen here. It's not just log 9 of x. If it was just log 9 of x, then his derivative would just be 1 over x ln 9. What we'll do is we'll put this stuff that's in the chain down below, and then multiply that by ln of the base that we didn't want, the 9. That's the ln b part. I mean, that's not completely finished because of this being a chain rule. We have to also multiply by the derivative of the inside, which would be 1/2 x to the negative 1/2. And so this should be our derivative. Now it wants to know, it says state the domain of the derivative. Let's analyze the domain of the original function first, because our domain of the derivative would be either equal to the domain of the original, or at least just a subset of the domain of the original. So things we look for when we're looking for domain are, we can't have division by 0, we can't have a square root of a negative, and we can't have a log of a non-positive number. So there's a couple things that could cause a problem here. I'm analyzing the domain of the original first. So we have to have here that x itself cannot be less than 0, because we cannot take a square root of a negative. Also, we have to find that 5 plus radical x has to itself be greater than 0 so that we're not taking a log of a non-positive number. So those are the two conditions that must be met. So I'll try to simplify. This one's already simplified. The radical x has to be greater than -5. That could never be a negative anyway, so it looks like that's always going to be true here. Because like even if x was 0, like a square root of 0 would just be 0, and that would be greater than -5. See, these are all the radical x's that are gonna be possible. You know, there's no way that radical x would be less than -5. So this is always true. So there's no problem with this one then. So what's the domain then? I believe the domain would be from 0 to infinity based on this, that it has to be greater than or equal to 0. Anybody who meets this condition, this is never gonna be negative. So that's our domain of the original. So just to check, I can't probably type in log base 9. I could do log of 5 plus square root x, and then I'll have to use change of base formula here. So log base 10 over log 9, that should do it. Yeah, as we can see, it's only defined on 0 to infinity. Alright, so that settles that question. Now we have to analyze the domain of the derivative. So this is the derivative. And so first of all, the domain of the derivative cannot include x's that aren't part of the original domain. We're limited, like right at baseline, to 0 to infinity. This x to the -1/2, I'm just going to rewrite that as 1 over 2 radical x. So if we combine this, we'll get 2 radical x times 5 plus radical x ln 9. We see that x cannot be less than 0 here and here, but we actually already have that taken care of already. Like there are no x's in the original domain that are less than 0 anyways. So this is fine so far. The only other thing that might cause a problem would be division by 0. So we have to make sure that 2 radical x times 5 plus radical x ln 9 cannot be 0. Alright, so some of these constants can just be divided into the 0. They go away. So now by 0 factor law, you got to break it up into 2 parts. So radical x cannot be 0, and 5 plus radical x cannot be 0. So this means that x cannot be 0. For this one, it just shows that radical x could not be -5, which is not possible anyway. So the domain of the derivative is therefore 0 to infinity.